everybody. It's Tuesday at 2 p.m. and it is the ROMKids Show. Nice to see you all here hanging out with us. Remember that this is a kids show right here on the ROM Toronto Instagram account. We're really excited to hang out with you today on the Season 2 finale of the ROMKids Show, part of our distance learning ROM at home sort of plan here at the Royal Ontario Museum. Today on the show, Veronica Di Cecco, mineralogist right here at the Royal Ontario Museum, joins us to talk about meteorites and meteorWRONGs and how you at home can identify if the rock that you think is from space is actually a meteorite. So I'm very excited to have her on the show today. It's been a wild season for us. We debuted season 2 at the Royal Ontario Museum with David Evans, a paleontologist here at the ROM, and we made dinosaur eggs later on in the season. You might remember that Mark Peck episode where we learned about passenger pigeons, which was like pretty cool. We also learned that the dodo bird is a relative of a pigeon, which is quite fascinating. Jeanette was on to talk to us about truth and the importance of telling the truth in museums. And we made our own little tree rings out of our hands to tell the story of our lives. Leet was on to talk about how exhibits are made and transported all over the world in museums, especially during a pandemic. That can be tricky. We've had a really amazing season. We also had Kim Tate on, Dr. Kim Tate on, to talk to us about BNU and sort of how 2020 was all about landing missions and sending substances and materials from space back to Earth. On the Leet episode, we also mummified an apple. And because it's the season 2 finale, I thought we would check in, see how our mummified apple is doing, and then we're going to begin our show. So I've carefully taken out, we mummified this apple in October. So let's see how our mummified apple is doing now. We used a similar process to ancient Egyptians, but of course we did it in a 2020 way. We used Epsom salt, baking soda, and salt, and we wrapped it all up in our apple. And then we coated it there, and we've left it for like 2.5 months now. And you can see it's not rotten, which is like pretty cool, right? But it's certainly dehydrated. Just how, I'm going to take it out and gesture with it, I think, is what I'm going to do. Whoa, mummified apple right there. We also have another one from the spring, but I'm going to leave that one in its container. But take a look at that. It's a really easy to do project. Every single project that we've done on the ROMKids Show, every single episode is up on the ROM website. Just Google ROMKids Show, and you'll find like 18 plus episodes right there. They're all up on YouTube, so we're live right now, and they'll be up on YouTube later this week, so you in your classroom or you at home can get into it later on, okay? I'm just going to wrap this up because, frankly, I want to revisit it in the winter. And with that, I think we are now ready for the theme song portion of the show. Let's get ready. Here we go. Welcome to the ROMKids Show with me. We'll do some crafts and tell some stories. Let's talk about science, art, and history. Welcome to the ROMKids Show, starring you and me. Last time we're doing that in 2020. What interesting and curious year. That's the theme song portion of the event. And now let's move right on over to the art table to get ready right in our activity zone. I forgot to mention I'm wearing space socks, but I am wearing space socks. You better believe that I try and stay on theme for our show. So today on the ROMKids Show, we are going to learn about meteorites and meteorWRONGs, and our activity is to learn about density, okay? So this is what we are going to do today. It's using various different substances, materials, that we can then test the density of the liquids inside of this, and then some of the objects we're going to top in. And then we're going to learn from Veronica how that can tell us if the rock that maybe we found that looks like a meteorite is actually a meteorite or a meteorWRONG. So what do you need? You need a container, okay? The tall container, if that works. I got like a nice little jar, probably held jam in it at some point, I don't know. But that's what you're going to need. You're going to need a jar. and it's going to need to be a see-through jar, okay? So that you can see all the layers of the substances that you're going to put right on in there. The next thing you're going to need is maple syrup. If you have honey, you can use honey too. You can use honey and then maple syrup, but we're going to stack all of these liquids on top of each other. So we got some maple syrup right there. You're going to need some soap, specifically like dishwasher soap, so that, something that has heavy grease-fighting abilities. You're going to need water. And as you can see in our water cup, we got some water right here. And then you're going to need some vegetable oil. All right, we got some vegetable oil right here. And finally, you're going to need some rubbing alcohol. And so right off the bat, adults, teachers, family members that are doing this with the kids in your household, this is, and I repeat, this is activity that needs to be supervised by the adult in the classroom or in the household, okay? So definitely get involved with your kids. If you're a kid, go get your adult team up time, okay? Because we're going to do this together. We just need an adult here to help you with it. So while we are all gathering these materials, it's time to welcome to the show our very special guest, Veronica Di Cecco, mineralogist, right here at the Royal Ontario Museum. Welcome to the show.
Hi, thanks for having me.
We are so excited to have you on today to talk about meteorites and meteorWRONGs, because this is something that you study here at the Royal Ontario Museum. So with that, before we get started, I want to do the first step, okay? The first step of our project right here before we dive into asteroids, comets, meteoroids, and what this all means for us. So the first thing you're going to do is you're going to take, and if you go up onto the ROM website, it has like a density chart right there too, and it gives you the order of substances that you're going to put in. So if you are using liquid honey, which is the densest of all the substances we're going to use today, put that in first. I don't have liquid honey at my house. So what we're using instead is we are using maple syrup. So you can use honey, then maple syrup, okay? And we're gonna describe like what density actually means later on in the show when we try to figure out what's going on with meteorites. So this is 30 milliliters of, maple syrup right here. I pre-measured that beforehand because it's kind of like a cooking show. And what I'm gonna do is I'm gonna pour it into my jar. And I'm gonna pour it right into the middle. Try not to get any of it on the sides of your jar, okay? So I'm just gonna pour right down the middle. And then what I'm gonna do right after that is I'm gonna pour my soap, okay? So honey, then maple syrup, then soap, then pause, okay? And we're gonna do that live right here. But first off, I wanted to talk with our good friend, Veronica. Something that you do at the ROM a lot are these things called ID clinics, ROM ID clinics. What are they and why are they so cool?
Yeah, so ID stands for identification. So we are looking at things that people bring in from the public. So this can be anybody. Anybody can walk into the museum on one of these days and show us what they think is really cool, and we'll try to identify it for you. So we're only doing it for rocks, minerals, gems, meteorites, and fossils. And we won't tell you how much it's worth, but we'll tell you whether or not it's worth holding on to.
Oh, I really like that. Whether or not it's worth holding on to. I like that. I like that. One of the things that often comes up with you folks is, did I find a meteorite or not, right?
Yeah, that's a really common question because, I mean, you see something cool in the sky and chances are it's near you, so you look around and you find something that you think looks really weird and you want to know if you've found the big one, right?
So then, right now, I think it's important that we try and define a couple celestial objects right here for our audience, so we all know what these different terms mean. So first, what is an asteroid?
So an asteroid is a larger planetary body. It's like about up to 100 kilometers or hundreds of kilometers wide, bigger than a meter. It's orbiting around the sun. It's made of leftover material that's still kicking around from the beginning of the solar system that never really got incorporated into something else. So this can be hanging out in the asteroid belt, or it can be somewhere closer to Earth, or just floating around out there in space.
Big giant rocks in space, as we get a notification from our good friend Shiza right there on the screen. Okay, so that's an asteroid, big giant rocks in space. They kind of have an orbit too. You find a lot of them in the asteroid belt between Mars and Jupiter. Okay, another thing we hear a lot about, comets. What's a comet?
So comets are kind of like asteroids in that they have some rock to them, but a big difference is that they also have a lot of ice and snow and dust. And so they typically come from further out in the solar system because things are much colder out there. And they start to move into the inner part of the solar system. They're starting to melt a bit, and that's when we see these big tails that go through the sky.
And you see that
still have an orbit to them.
You can see that big orbit. You can see that big tail right here, because as you get closer to Earth, you're getting a little bit warmer, and you start to melt a bit. Okay, so we know what an asteroid is, big giant rock. We know what a comet is, a lot of ice. What is a meteor, a meteoroid, meteorite? Like, what's going on there?
Okay, yeah, so those are all really similar sounding. So a meteoroid is like an asteroid, only it's smaller. So it's up to a meter large. You can see it with your eye, so you don't need a microscope to see it. Still floating around in space. It's called a meteor when it's actually entering our atmosphere. And that's when you see these bright lights through the sky. They're starting to burn up in our atmosphere. And if it lands on Earth and it survives that burn up, then we call it a meteorite.
And so right here, I have a meteorite. Thank you, Julie Tomei, from the Learning Department, for letting me take this home with me. This is a meteorite here. So this came from space. I'm holding a space rock in my hand. You are seeing it on our screen. Now, this is kind of a special meteorite too, right?
Right. So not all meteorites are made equal. The one you have there is actually a very rare kind called Palacite. And we kind of think of those as like stained glass windows of meteorites. They have chunks of olivine in them, which the gem name is peridot, and they also have a lot of metal. That metal is iron nickel metal, and it's a very common metal that's found in meteorites, but it's very rare to see them in that pattern that you have in your rock right there.
So we got that. We're going to come back to that in a bit. I'm going to show some pictures that you sent me of meteorite. Can you explain how these are more common?
So actually, the one that you're holding up right now, can I look?
Yeah.
That one is a meteorWRONG. See, I fooled you.
Oh, it's a meteorWRONG. Okay, let's go to the meteorite first then. This one.
Yeah, that one. So that one is a meteorite, and there's a couple telltale features that we look for in them. Are we going into that now?
Yeah, sure. Let's talk about that.
Okay, so some telltale features that we look at in that rock that you have a picture of right now. So meteorites are rocks, just from space. That one there, it has a fusion crust. So that is an outside that is kind of glossy, kind of like if you think of a ceramic teacup, a little bit of a shine to the outside of it. And the outside looks different from the inside. So the picture, the one you have there, it's actually been cut up like a loaf of bread. So we took a slice off the front of it. And if you have tile saw, if you have a cool rock, you can beg one of your parents to cut a slice off for you one day, and you can see if your rock has an outside that looks different from the inside. That's a very important feature of meteorites. It tells us if we have this fusion crust. The fusion crust only forms if something is entering our atmosphere and has started to burn up and melt on the outside. So that's why we look for it in rocks, because we're not going to find it in a terrestrial rock, in a rock from Earth. We'll only find it in a rock that came from outside of our planet.
Because of all the friction when you're coming through the atmosphere, it burns up. And so you can sort of see on like this one, it's like it's a little bit. It's again, the really heavy ones at the ROM, which I did not want to carry home. Show it a little bit better. This brings us to an important question before we get into meteorWRONGs.
Yes.
Where do meteorites land the most?
So they land everywhere, all over the Earth in an even amount. But because the Earth is, I think it's like 70% ocean, most meteorites land in the ocean. So even distribution all over the Earth, but that means odds are we're not going to find them because they land in the water. You are more likely to find them in places that have snow or sand, but that's more because they're easier to see than they're more likely to land in those places.
That tracks.
So we don't find too many in Ontario because we have so many rocks and trees, and they kind of just blend in with everything else.
So meteorites they land everywhere. If you're in an ocean, you're not going to find it. If you are in a desert, which is either a sandy desert or a snowy desert, you're more likely to find them because the darkness of the object stands out against the ice and white of like a polar region, or like the sandiness of a desert. So you're most likely to find those there. Okay, let's define a little bit more about what a meteorite is. But first, I just want to demonstrate to our friends in their classrooms or at home. You can see that maple syrup layer, that delicious, delicious maple syrup layer, followed by that soapy layer, okay? And you can see that soap, which we all love. Like, we love soap, especially in this household, for cleaning our hands and keeping us safe. It's all bubbly, and it forms right on top. And that's because the maple syrup is denser than the soap. And I'm going to do the next step in a second, because maybe you're doing the honey, maple syrup, and soap. We know that characteristic of a meteorite is that fusion crust that happens when it comes to the atmosphere. What are some other characteristics of a meteorite?
So one big one that we'll get into with your density column there is that meteorites are dense. So this means if you hold up two things that are the exact same size, one of them is going to be heavier than the other, and that heavier one is denser. That's because it's made up a lot of metal. So meteorites often have metal in them, iron, nickel, metal, and this metal is also usually magnetic. Meteorites aren't always magnetic, but it's a good sign that your rock is magnetic, that it could be a meteorite. That's not to say that rocks on Earth aren't magnetic. There's lots of things on Earth that are magnetic too. It's just one of the things that we check for. Another big one is bubbles. So if you think of like an Aero chocolate bar and all those bubbles that are inside your Aero chocolate bar that taste so good, you don't want those in your rock, because it means that your rock cooled so fast that those bubbles got trapped like they were in glass. So that means that it's more likely to have formed on Earth. We don't really find bubbles in any rocks that come from space because they cool very, very slowly, enough time for all those bubbles to float out.
Huh, that's really, really interesting. Okay, so we learned a lot about the characteristics. So if you have rocks at home, keep in mind, does it have a fusion crust? Is it really, really dense? Does it have bubbles or not? Okay, moving to the next step. So the first one, you can just dump pour your honey, your maple syrup, or your soap right in, keeping in mind that you do not want it to touch the side, because that way it will mix together, and we don't want anything to mix together. Your next step, once you move to the water, your vegetable oil, and your rubbing alcohol, and again, you're doing this with supervision, adult supervision in your household, is, hi everyone, nice to see you. Thanks for everyone checking in on the group chat. Is you're going to take a eyedropper or a turkey baster. We don't have a turkey baster in this household, so we have a very small eyedropper that we're going to use. And what you're going to do is you're going to take your water, pull it right on in. Here, let me just do that better for everyone at home. You're going to put your eyedropper right into your water, pull up all the water right into your eyedropper. And instead of pouring it right in, because the momentum of it will sort of have it mix with the layers below that, and we don't want to do that. You're going to take your eyedropper and just let it stream down the side of your jar. Okay, did you catch that? I'm pulling up the water, and then I'm pouring it down the side of our jar. This is a lengthy process, but it means that your layers stay more distinct, and make sure that when we do our density experiment later, you can see it more distinctive, okay? You can see every layer separated so that we can see where things actually land. Okay, moving back into, we've done our meteorites. So what are some meteorWRONGs?
So a meteorWRONG is just a fun name for anything that's not a meteorite. And there are a lot of things out there that look like meteorites. So Kieran's holding up a picture of one. This might look familiar to some of you. It had me stumped because I couldn't remember what it was. Yeah. But that is a piece of asphalt. So it's just from the driveway or from the playground. But because of the way it's shaped, it's black. It's got bits of other stuff in it that looks really cool. Just a man-made material. So meteorWRONGs are anything we think might be a meteorite, but isn't.
Okay, so I have a couple things here that are meteorWRONGs, and we identified them in the pre-interview, and I'm just hoping that we can remember what they are. Okay, so this
It'll
one.
be a test.
What is this one?
Ooh, can you tell me something about it? Does it have holes?
It has holes. It's black. I can see through some of the holes. It is very light.
Is it magnetic?
Let's test. It is not magnetic at all.
So I think that one, from when we looked at it before, is a piece of a volcanic rock called basalt.
Basalt.
So it's a little bit heavier than the other one you have, right?
Yes.
Yeah, so that one's called basalt. So it's a dark rock. It's got lots of little bubbles in it. These bubbles actually the Earth formed them, but it's not that common for something from this area.
You're not going to find them in, like, Toronto, but you might find them in Hawaii.
Yes. But one looking at that rock is the outside looks the same as the inside.
Yeah.
So it doesn't have a crust on the outside of it.
No crust. Remember, that's a characteristic of a meteorite. Is this also a basalt?
I think that one might be the slag. Is it shinier?
It's shinier.
Is it magnetic?
Let's test. Not magnetic at all.
Oh, interesting. So slag doesn't always have to be magnetic, but you were holding the most commonly mistaken thing for a meteorite because it looks so weird. It's actually a man-made material called slag. A lot of these things are man-made. Turns out people make weird-looking things. But slag is left over from the smelting process. Basically, when we're working with metals and we want to take out all the good metals and leave all this stuff we can't work with behind, there's all this waste material. And people have used it in many different places. It's common to be used in railroad tracks. Find it everywhere. People have told me that it's hit their car on the highway. It turns up in the most unlikely places, farmers' fields, but it is a man-made material. A common sign is those bubbles. Sometimes they have flow marks in them. They can be magnetic sometimes because they have lots of iron in them, but no fusion crust.
Okay, so what we've learned is that human-made products like slag and asphalt are often mistaken for meteorites. And it's okay. You can see something and be like, that looks super cool. That's your curiosity speaking, and you should encourage that. And then the scientific process after that is to look into it, all right? And
not gonna lie, looking at my own rock collection I had as a kid, most of it was concrete.
Whoa! And that's okay, because as long as it brings you joy, right?
Exactly.
So as long as your rock collection brings you joy, you're doing just wonderfully. So these two things look very much like a meteorite. I honestly think they do too. But we got volcanic rock at the top and we have slag at the bottom, not meteorites. Okay. One question that probably comes up a lot for you is, are meteorites valuable?
Sometimes, but not enough that you're going to have to quit your job, unfortunately. So it is like finding treasure. It's like finding diamonds in the rough out there in the real world. But they are, so that you can buy them, you can trade them. They're not going to be equivalent to buying a new house. Some of them are more rare than others. It's kind of the luck of the draw.
I think it's one of those things where it can be really, really cool to you, but it's probably worth and more valuable to science
exactly
than it is for you trying to profit off them.
Yeah. So most meteorites are something called ordinary chondrites. As the name implies, they're pretty ordinary, although they come from space. Not super valuable, but that's something like 90% of all meteorites are of that type. You can get really lucky and find ones that come from Mars or the moon or those Palacites that you have a piece of there. That's actually the interior of a planet that no longer exists, just to drop that right there.
What? That's awesome.
So when we find things like those are super cool, but that only makes up, the one you have there, only 2% of all meteorites are that kind.
Okay, so 2% of all meteorites are a Palacite, and a Palacite is what's left over from a planet?
A planet that longer ago. So basically there was a planetary body that formed. It was big enough that it had enough heat going, the metal moved to the center, and the rocky stuff moved to the outside. But then one day, it got blown up. And that's why we're actually able to see the inside of it now and have pieces of it bloomed on Earth.
So
I know there was a lot to throw out there, really.
No, that was good. That was good. For longtime viewers of the show, we covered the formation of the solar system and the Earth last week on our transformation episode. So if you didn't see that, go back to that. And if you go back to September, we did an episode all about volcanoes where we cover this as well. So if you're a classroom or a household that's fascinated by that, Rom at Home, ROMKids Show, dig into the archive. We got so much good content for you there. Okay, I think it is now really important for us to define some terms before we do our density experiment. So again, we've been working on our little density column here. I'm not going to do it all because, as you can see right over here, I did it on the weekend, and I don't want to waste all of our materials. We're quarantining right now, and we don't have a ton of stuff in our household. So we got, you can use honey at the bottom, followed by maple syrup. Honey's denser than maple syrup, and then we put on the soap on top. We've then started to put a layer of water. After that, you put your 30 milliliters of your vegetable oil, and then you put your 30 milliliters of your rubbing alcohol. Remember, from water on up, you have to use an eyedropper or a turkey baster, and you need to you need to stream it in against the side because you don't want it to drop through the other layers, because if that happens, then they might mix together and then your density experiment might not work too well. So before we get to defining density, we need to define two other things.
Yes.
So first, what is mass?
So mass is the amount of matter that makes up an object. And so you typically see things like grams or pounds. Grams is really the one you should be using in Canada. And that is a measure of how much mass an object has.
Okay, so then the next thing we need to identify, and mass and weight are different, right? Because
they are.
Weight is defined by gravity. So if you're on the moon, you're going to weigh less than you do on Earth. So mass and weight are different.
That's kind of why you shouldn't use pounds.
There you go.
Grams is how we measure it.
I like it. Next, we need to define volume.
Yes. So volume is the amount of space an object takes up. It's like filling up a balloon. It has volume when we fill it up.
So
more volume.
A bigger balloon has more volume than a smaller balloon.
Right.
Okay, sweet. So I like that. And now getting to our word of the day. What does density mean?
So density is a measure of how much mass in a given volume. So when things are very dense, they're very heavy for the size that they have. And when things are not very dense, they're very light for the size that they have.
Okay, so if I'm understanding this correctly, this magnet and this tomato are roughly the same size. Okay?
Right.
This tomato is lighter and this magnet is heavier.
Right.
Which means,
so which one is more dense?
So that means that my magnet is more dense because there's more mass in it, and my tomato is less dense because there's less mass in it.
Right.
Okay. So then, using my curiosity brain, putting on my imagination goggles, I'm going to make a hypothesis here. Okay?
Yes.
That in our density experiment right here, and what I'm going to do is I'm just going to pull up real quick everything that's in our column here. You can see there is maple syrup. You can see there is dish soap. You can see there is water. You can see that there's vegetable oil and rubbing alcohol. Again, parents, you are supervising and are involved. Teachers, you are involved with this activity. This is in the order of their density. So, for example, here, the rubbing alcohol is the least dense, followed by the vegetable oil, followed by the water. The soap is more dense, and then the maple syrup is the densest, correct?
Right.
So, with that in mind, we are going to drop some objects in here and try and figure out what's more dense and less dense. Because essentially, we know that meteorites are very dense.
Right.
And so if we have an object that we found that we think is a meteorite, you could put it in this type of solution to check out its density. And so
you could.
You could.
Have a mess to clean up.
We are not on this show. We are not going to put the meteorite in here. We're going to use this bolt instead. which is a similar sort of property. And so
so bolts are made of iron and carbon, and meteorites have iron and nickel in them. So they're pretty similar in that regard.
Oh, perfect. We are sort of in line with how science actually works. So I'm going to drop in here this bolt. My hypothesis is that it's going to go straight to the bottom.
I think I'm with you on that one.
Okay, let's find out. Here we go. First part of our experiment, dropping it right in here. Oh yeah, that's right at the bottom. That is right at the bottom. It's that delicious maple syrup makes it really hard to see, but it's right there. It's right at the bottom. So hypothesis, which is like a scientific guess, it matches with what happened in real life. So the next thing I want to test, and we will be testing a rock, everyone. We will be testing a rock.
Okay.
Is I want to test this tomato. Okay?
Delicious.
Another tasty substance, exactly. I think that this is not as heavy, or sorry, not as dense as the bolt that we dropped in. So I'm thinking maybe this will be in the middle somewhere.
Yeah, I think that's a good guess because tomatoes are mostly water, right?
Okay, so here we go. Let's try it out. This has admittedly been sitting out in our household since Sunday, so there has been some evaporation. Let's see what happens. Whoa! It's like right there in the middle.
Nice.
Can you see that, everyone? That's so cool. We're testing out the density of that tomato, so clearly less dense than our bolt that went straight to the bottom. It's sort of between or around the layer of the water in the soap. That is so cool. Just suspended right there. Wow, learning so much about density. That is dope. Now, we did not define what this object was earlier in the show. Do you remember what this is?
That's your really light rock?
Yeah, it's a really light rock. It's a grayish white.
Yeah. So that one is a piece of pumice. So your parents might have this. People often use it to clean off their dead skin. But it is very, very light. It's filled with holes. It's basically like Swiss cheese rock, if you want to look at it, or the Aero chocolate bar of rocks as well. Those holes make it less dense. Spoiler.
Okay.
Alert.
Definitely feels less dense. It's the lightest thing, the least dense thing I think we have here. I think this is going to be near the top.
Yeah, very, very good guess. I'll give you a fun fact about that after you put it in. We'll see what happens.
Okay, let's see what happens right here. Because it looks like a meteorite. Let's try it out. Oh! It's right at the top. It's like right in that rubbing alcohol layer, sort of right on top of our vegetable oil. Look at that. So we got a bolt at the bottom. That's the densest thing. Then we have our tomato right in the middle, clearly less dense than our bolt. And then right at the top, that's a rock. That's a floating rock. That's a floating rock right there, right at the top.
That's what we see in nature too when those pumice stones are formed. They're actually a volcanic rock that erupts from a volcano, and when they land, they usually are in areas with lots of water and actually float on top of the water in the area that they form.
That is so cool. We've learned so much today, but I think the fact that rocks can float is one of the coolest things. Like, we learned about density, we've learned about mass, we learned about volume, but floating rocks? So, that is something that sometimes comes to you as something that people think is a meteorite. But as we've learned today, there are characteristics, as we wrap this up, there are characteristics to a meteorite. Characteristics of a true space rock are a fusion crust. Okay, so as it enters through the atmosphere, it burns up, getting a nice crust on top. They are very dense, meaning there's lots of matter in there. Okay, very, very dense. They don't have bubbles in the same way that maybe rocks on Earth would have. And often, they are magnetic, okay? Often, they are magnetic. We know that objects on Earth that are human-made, such as asphalt and, slate? Slag, are often thought to be meteorites, but they're meteorWRONGs. Again, they are not dense at all. And we also know that volcanic rocks, stuff that's spewing up from the center of the Earth, also often gets mistaken for meteorites, but they are a meteor-wrong. We are wrapping up, but the last thing I want to ask you, Veronica, because this has been so much fun. What a great way to wrap up season 2 of the ROMKids Show with our good friend Veronica. Is you are a mineralogist, you study rocks, you study space. If someone out there, someone in a classroom or someone at home wants to become a mineralogist just like you, what do you do?
Important question. Have a love for rocks. Very important. Never go into something you don't love. Number two is to study all the sciences. So geology is great in a way that you can study physics, you can study chemistry, you can study biology, and put them all together to study the Earth. So basically, just figure out which one of those you like most. I have a degree from university in an undergrad degree, and I have a master's degree. So using those things together, I work on a lot of different things here at the ROM, and it's a really fun place to be.
Veronica is like one of my favorite people at the ROM. She often talks to our kids right here at camp, and we can't wait to be back at the ROM running Saturday Club, Summer Club, all those great things. One of the things that we talk a lot about on the show as we close it on down is that you can be a scientist even if you're a kid, okay?
Oh, definitely. You proved that today.
We proved that today by doing by coming up with some scientific ideas and questions and then testing them, such as our density experiment. We know with our episode with Antonia that you can go right outside and look at bugs and take pictures. From our episode with Mark Peck, we know that you can go outside and look at birds. That's how you can become engaged with the scientific community. And we can also have rock collections too.
Definitely. And I had a rock collection growing up. I think a lot of people do, even if they won't admit it. But the most important things when you have a rock collection, pick something you think is cool, and you need 2 very important pieces of information. What is it, and where did it come from? So very important to keep a note of those things, because without either one of them, it doesn't really have as much significance. You need to know what it is and where did it come from.
What it is and where did it come from. If you find something cool and you think it's a meteorite, write that down, take some pictures, get involved with the scientific process. And with that, that's it. That's the conclusion of, hey, we have a question right here before we close it on down from the group chat. What about teens that are the age of 10 to 20? What are some things we can do there? I have an answer, but let's hear from you first.
So there's actually a group called the Young Toronto Mineralogist Club. There are young rockhound clubs out there all over the world where kids get together virtually right now, but talk about their rock collections, learn from other people who have been collecting them over time. Another important thing is always just go outside. Just go outside and be interested in what's around you and ask questions. And if you see something you think is weird, go home and look it up. And then obviously go to museums. I mean, very important thing to do.
We have a pretty great camp here at the ROM and we can run them. That's a great place to go. My bad, age 19, 20. I think that's still the same though, right?
Yeah, definitely. I mean, I've had a rock collection my whole life. Keep going. 19 or 20, you're starting university, so you can, or college, and you can see whether or not there are programs or degrees out there that are applicable to what you're interested in. If you wanted to keep it up as just a hobby, there are mineral and gem shows that happen all over the world. Again, not right now, but people sell them still online as well. And people collect, or you can just learn more about the world around you and what our everyday products are made of at home.
And that's also taking part in the ID clinics that the ROM does too. Right now they're virtual, but eventually, again, they will be on site. And that's a great way to see what other people in your interest field really enjoy. I would say finding safe parts on the internet too. There's lots of communities where you can do that. And what, again, is really special about insects, birds, and rocks is there are thriving hobbyist communities where even though you might not have a doctorate degree, there's still a lot of interest in science that is taking part in those communities.
Yeah, definitely. And another thing is, even though the ID clinics aren't happening in person, we're still identifying things for people online. If you send it an email to the museum and ask a question of what it is that you have, or you send it through Instagram or Facebook or Twitter, all those things, eventually they make their way through the museum to somebody who can answer your questions for you.
hit me up. I'm Kieran C. Mukherjee on Twitter and on Instagram, and I'm happy to get all of your questions to the people that need them. But with that, I think we're all wrapped up season 2 of the ROMKids Show. We had so much fun this year. They're all up on YouTube, so if you missed them and over the December break, you want to see some of them, do that. Teachers, feel free to reach out and we can have some shows that fit the content that you need. But with that, thank you so much. Everyone stay safe. Wear a mask. We love you, and we'll see you again for season 3 on the first Tuesday of January. Bye, friends. Have fun.
Bye.